All right, so you ready to get kind of nerdy with me and decode some programming logic?
Always up for a good code-breaking session.
Perfect, because today's deep dive is all about something called the modulo operator.
Ah, the modulo operator.
You know that percent sign, the percent you sometimes see in code.
Right.
We're going to figure out what it actually does
Okay.
using these examples and visuals from the sources you sent.
Sounds good.
And then we'll get into why it's so darn useful.
Okay, so starting with the basics.
Yeah. I'll admit, when I first saw the episode topic, I was like, the percent sign? Really?
Yeah, it doesn't exactly scream exciting, does it?
Not really. But then going through these sources, it's everywhere.
It really is. It's one of those fundamental operators that kind of sneaks up on you.
Yeah, exactly. Like in this 2.1 poor.pdf file.
Okay.
There's that example. 23% 10 equals 3.
Right.
So it's like we're back in grade school doing long division.
Exactly. It all comes back to the remainder. We're focused on what's left over after the division, not the result of the division itself.
So it's not the math itself that's special, it's what we do with that leftover amount.
You got it.
Okay, so let's get visual with it.
Love it.
This first image you sent, 2.12 modulo visual example.pne.
Yeah.
It's a flow chart,
Okay.
which always helps my brain kind of visualize things.
For sure.
We start with x5, multiply it by itself.
Right.
Simple enough, then the output is 25.
Okay.
Where'd that come from?
So the modulo operation isn't actually directly shown in this particular visual,
Okay.
but the output kind of highlights the overall effect.
Okay.
25 modulo anything would give you 0 as the remainder. So this emphasizes a key point. Modulo isn't about the calculation itself.
It's about what remains after that calculation's been performed. So it's like we did this whole bunch of math behind the scenes, but the modulo operator just cuts to the chase.
Yep.
And tells us what's left at the very end.
Exactly. It gives you that one crucial piece of information, the remainder.
All right. I think I'm starting to get it.
Good.
But I'm still wondering, do people actually use this in the real world?
Oh, absolutely.
Or is it just some cool math trick?
Oh, you better believe it's used in the real world, and way more than you might think.
Really?
Yeah. Image 2, 12.2 modulo user minutes to hours.pne shows a really practical scenario.
Okay.
Taking a number of minutes and figuring out how many hours and minutes that represents.
Oh, yeah. Like if you've got some meeting that's 137 minutes long, which, ouch, who scheduled that?
No thanks.
But instead of saying 137 minutes, it makes more sense to say 2 hours and 17 minutes.
Right.
It's way easier to wrap your head around.
And that's exactly what modulo helps us do.
Okay.
If you take 137 minutes and apply modulo 60, because there's 60 minutes in an hour, you get 17.
Okay.
That 17 represents the leftover minutes after you've accounted for the 2 full hours.
Wow, I never realized that's how that conversion worked.
Yeah, it's modulo behind the scenes, doing its thing.
That's so cool.
It's very efficient, cuts right to the essential information.
Yeah, I'm already seeing modulo's real-world potential here.
Oh, yeah, this is just the beginning.
And from the looks of the other examples, 27% 4, 596% 10, and so on, it seems like we're not just limited to time calculations, huh?
Nope, not at all.
Which leads us right into image 4, 2.13 datatypes.pne.
Oh, okay.
This table lists different data types used in programming: integers, floats, strings.
The building blocks of information.
So what does this have to do with modulo?
Well, this is where things get really cool. Modulo's magic is that it's not restricted to just one data type. This flexibility is what unlocks a universe of applications.
So whether we're dealing with whole numbers, decimals, or even text, modulo is there to help us out.
Exactly. It's like having a universal tool in your programming toolkit.
Oh, I like that. So we've established that modulo is actually useful.
Absolutely.
But before we get into all that,
Yeah.
they actually provided some modulo puzzles for us to practice with.
Oh, fun.
In image 3, 2.1 modulo challenge.
Okay.
I always love a good brain teaser.
Me too. Me too.
All right, challenge accepted. Let's see. So we've got this first puzzle,
Okay.
50 per 6,
All right.
and if I'm remembering this right,
Yeah.
it's all about finding that remainder.
That's right. Okay.
We're basically asking,
Yeah.
how many times does 2 fit evenly into 50?
Okay, so 2 goes into 50. Well, 25 times.
Exactly.
Nice.
And because it divides perfectly,
Yeah.
we're left with nothing remaining.
So the remainder is 0.
Exactly.
Which means 50%, 2 equals 0.
You got it.
Got it.
Nailed it.
I feel like I'm back in math class, but in a good way.
It's all about breaking down these operations into their fundamental parts.
Right.
But these basic principles are what make modulo so versatile.
Okay, so speaking of versatile,
Yeah.
you mentioned earlier that modulo pops up in all sorts of unexpected places.
That's right.
Like cryptography, for example. It's true.
I have to admit, that one really caught my attention.
It's one of the more fascinating applications, I think.
It's like, okay, Modulo, I see you. You're hanging out on my computer
Yeah.
doing all this important work.
Glitching behind the scenes.
To be honest, I don't really understand how all that information is kept secure online.
Yeah, it's kind of a black box for a lot of people.
It really is.
Well, that's where modulo comes in.
Okay.
It plays a really important role in a lot of the encryption algorithms that keep our, online activities safe.
Wait, hold on.
Yeah.
You're telling me that little % sign is helping to protect my credit card info when I'm online shopping?
That's right.
What?
Yeah, modulo is on the job.
No way.
To illustrate, one pretty famous encryption method is called RSA. Don't worry, we won't get into the weeds of the technical details.
Okay.
But essentially, RSA relies on the mathematical properties of modulo and prime numbers to create really secure keys.
Keys. Like a digital lock-in key.
Exactly. Imagine you want to send a secret message to a friend.
Okay.
You can use your friend's public key, which is based on modulo calculations, to scramble that message.
Wow.
So it'll look like gibberish to anyone trying to intercept it.
Gotcha.
But then your friend has their own private key, also linked to modulo, to decrypt the message and read it.
Wow. So Modulo is like the secret ingredient in these digital keys.
That's a great way to put it.
That ensures that only the right people can actually unlock the message.
That's right.
That's amazing.
Yeah.
Okay, so cryptography, that's one thing.
Right.
What else? What else can Modulo do?
So another area where modulo is super useful
Okay.
is pattern recognition.
Hmm.
And this might seem a little bit different from cryptography, but bear with me.
Okay. All right.
Think about things that have a kind of cyclical nature, right? Like the days of the week, the hours on a clock.
Right, it resets after 12.
Exactly. Or even musical scales. They all involve these repeating sequences.
Yeah, and they follow the same order over and over.
And modulo helps computers understand and work with these repeating patterns.
Okay, I think I'm following so far.
Okay.
But how does that actually work?
Well, when you use modulo to analyze a sequence,
Yeah.
you know those remainders we keep talking about?
Mm-hmm.
They'll start to form a pattern of their own.
Really?
If there's some underlying cycle to the original data, so you're basically using modulo to reveal these hidden relationships within the data itself.
Oh, so it's like Modulo can see those hidden patterns that we might not even notice right away.
Exactly.
That's so cool.
And once the computer recognizes these patterns, it can use them to predict future elements in the sequence, identify anomalies, or even generate new data that fits the existing pattern.
So, like, if you fed a computer a bunch of musical notes using Modulo, it could theoretically compose new music in the same style.
That's the idea.
That's amazing.
Yeah, modulo essentially helps computers understand the underlying structure and rules of these patterns.
I'm honestly blown away.
Yeah.
I never would have guessed that something as seemingly simple as finding a remainder could be so incredibly powerful.
It really is quite remarkable.
It's like we've uncovered this secret mathematical code that unlocks all these hidden patterns and possibilities in the digital world.
That's a very poetic way to put it.
Well, I'm feeling inspired. But seriously, this modulo operator is like the Swiss Army knife of mathematical operators, small but mighty.
It's a testament to the elegance and power of mathematics, wouldn't you say?
Absolutely. It's those fundamental concepts that often end up having the most far-reaching impact.
Well said.
You know, it's funny how we often think about technology as this super complex thing,
Right.
but then you dive into something like modulo.
And you realize it all comes back to these really elegant mathematical ideas.
Exactly. It's like we've uncovered this hidden layer of the digital world that's always been there.
Quietly working its magic behind the scenes.
It makes you appreciate the ingenuity that goes into building all this stuff we use every day.
It really does.
I feel like we could do a whole series on modulo at this point.
I'm in.
But for now, I think it's time to let our listeners loose.
Armed with their modulo knowledge.
To go out into the world and start seeing those % signs everywhere.
They'll never look at a % sign the same way again.
I know, right? Any parting words of wisdom for our modulo explorers out there?
Absolutely. Keep an eye out for those repeating patterns, those cycles in everyday life.
Ooh, like a modulo treasure hunt.
Exactly. Your digital clock, the way a playlist loops on repeat, even the changing seasons.
Ooh, I like that.
Modulo's fingerprints are all over the place once you know how to look.
It just goes to show that math is everywhere.
It always has been, always will be.
Well, on that note, I think it's time to wrap up this deep dive into the wonderful world of modulo.
It's been a pleasure exploring with you.
The feeling is mutual. And to our listeners, thanks for joining us.
Until next time.
We'll catch you on our next Deep Dive.